Architecture is really important. It usually means the difference between success and failure. When Edison introduced his direct current dynamo technology, there was a lot of excitement about the potential of electrification. There were demonstrations and proofs of concept. Ultimately, however, the DC architecture would not scale. It took Westinghouse attacking the problem with a new alternating current architecture for electrification to move beyond the breakthrough barrier and change the course of human history. AC architecture allowed for a radical redesign of manufacturing, moving from power-oriented factory configurations to production-oriented configurations. It also ushered in widespread domestic illumination, the appliance industry, and of course, modern computing. Blockchain is kind of in the same situation. The 2008 Nakamoto paper was revolutionary and showed us that a usable digital proxy for trust was in fact possible. Digital trust is an enormously powerful primitive upon which all manner of next-generation multi-party, ecosystem, and multi-sided marketplaces will be built. So it should come as no surprise that there has been a lot of excitement about it, as well as a lot of investment going into it. The problem is that the original blockchain architecture was designed to solve the cryptocurrency double spend problem. Many companies have tried to hack it and extend it so that it can be applied to other use cases, but in doing so, they've introduced complexity and given up Turing completeness, that is to say, the ability to perform in a generalized way. They've also tried and failed in most cases to address the selective privacy requirements of enterprises in a completely satisfactory and pragmatic way. They've made it difficult and often ultimately unacceptable trade-offs between decentralization, privacy, and scaling capabilities. They also typically feature a very high total cost of ownership. The fact that most of the blockchain platforms suffer from some fundamental architectural defects and are on the wrong side of the breakthrough barrier as a result is why many industry analysts have been advising their clients to plan for their proof of concept projects to be migrated to a next generation platform in the 2021-2022 timeframe. Traditional blockchain architectures have scaling limits owing to their network, computational, and storage architecture, as well as their consensus mechanisms. As these limits are approached, these systems become exponentially more expensive. Insolar has rethought distributed ledger technology and has implemented a novel born-in-the-cloud architecture. It has made a number of significant technology breakthroughs that allow it to move beyond the breakthrough barrier, to become that trust-enabled distributed application platform upon which next-generation business applications can be deployed at scale. This architecture allows it to scale to large production implementations with low and very predictable TCO. There is no limit to throughput, and networks can be scaled with linear performance and TCO characteristics. This is obviously advantageous and significantly improves performance, cost, and freedom of action.